what if things got a little bit more complicated? So right now I can print everything out and everything looks good, but what if instead of a time increment of 0.1 seconds, I wanted to go to a time increment of 0.01 seconds? So I want to look at 100 numbers. In which case things become a little bit more challenging to look at in sort of this format. And so what I like to do in this case for debugging is I like to plot. So if I print every line of code that I print and makes no sense, I like to plot. And I have no memory, so I'm just going to grab this plotting function from over here. And in this class, we're primarily going to be using a plotting library called matplotlib. There's a number of other plotting libraries that are also available online. And so we're going to import this matplotlib and we're going to call it plot. And I like just putting all my imports at the top. So what I'm doing is I'm going to create a plot that creates time as the x-axis and p as the y-axis. It prints it in blue and it prints it with a dot. And it reads it with some sort of label. So we can say that this is some sort of sinusoid function. It'll create a legend in the upper right. It'll create a Y label, an X label, and then this plot basically just says, show it. And that is not correct. How is it getting that? It's going up to 0.5. Huh. Very, very odd. Okay, let's debug it. Okay, debugging time. So let's go back to 0.1 because I think that worked. And I'm dealing with a P that goes to 10 and ends at 5. And if I were to print it, that does look correct. And maybe let's just play around with it while we're here. Maybe I just want it, I want to get rid of those dots. I can get rid of the dollar signs if I want. The dollar signs just basically tell it to print it as a LaTeX variable, so it looks pretty. So now it just prints it as like a normal print string. I like using the dollar signs. I think they're nice. And so let's go back to what we did before and change this to 0.01 and rerun this guy and rerun our P. What is going on? And so it's saying, I see. So I said basically go in 0 to 11, but that's no longer the size of my array. So what I might want to do is replace the start and end, the start and stop, with maybe just, I want to loop it over the size of time. And so I can replace it with np.size of t. Now remember, j always starts at 0 by default, so I can just get rid of that first number. But if I wanted, for example, to start at some j equals 5, I would then just add a 5 to the beginning of the statement. So this assumes that I'm going to go from 0 to the size of t, and I'm going to fill it. And so now what you'll see, you have a sinusoid function. Let's see if it's correct. It starts at 0. It goes to 0.6. There is a sinusoid function with an amplitude of 10, and then it's 0 after 0.6 seconds. So this to me looks pretty good. So that was a quick example of debugging. So a lot of things are associated with the size. So I've manipulated the size of time, and so it didn't fill. It only filled a portion of this P array. Let's go back to 0.1 seconds, and let me show you another sort of common mistake. So another common mistake is trying to create vectors and compare them when maybe they're not equal. So if instead of saying that I wanted this to be a NumPy array that was the same size as time, let's say I thought I was being smart and I just said it was of size 10 because I knew that there were 10 points. Or I thought there were 10 points. And so if I go run this, what it's going to say is index 10 is out of bounds for axis 0 with size 10. What it's doing is it's created, if I go back to my Excel spreadsheet, it's created an array of zeros that's only 10 long. But it's looping over the size of time, which is 11 long. And so what it's doing is it's good, it's good, it's good, it's good, it's good. And in fact, I can even print j when it's not good, and it basically goes from 0, 0, 0, it gets to 9, And then something crazy happens. It tries to access some point 10, but there's no P that's there to access. It's not long enough. And so it tries to see, T at 10 is greater than 0.6, so it's on this else statement, and it's trying to say that P at 10 equals 0, but there is no P at 10. And so it says index is out of bounds. And so it's kind of helpful sometimes to write this in terms of the size of something else. And you see now it completes the entire thing. So printing J can be very helpful, and printing P can be very helpful. And you see now that everything is right again. So one thing that I might want to consider is maybe I don't really like printing this out in terms of rows. Maybe I want it to be in terms of columns. In which case I might say, I might pass something that instead of having the size of T, maybe I want it to be of size of rows that are the same size of time, but then I want it to be one column. And then instead of saying I'm going to pass P at J, maybe what I really want to pass at P at J, which is the row at column 0. And it didn't like that. Data type not understood. NP.size of T. Does that take a tuple? It takes a tuple. Boom. And so now what I'm doing is I've created this 0 array, if I print this initial 0 array P, that's in terms of columns rather than rows. And then I'm filling basically each row at column 0. So this is, it actually has 2 indices associated with it, 0, 0, 0, or 1, 0, 2, 0, 3, 0, where that first number corresponds to some sort of row.